Hello everyone, so this is the last lesson for the topic of transformations. Don't forget, transformations, we said we're transforming from a shape, okay? By using 4 different elements, either through translation, okay, reflection, rotation, or enlargement. We've dealt with the first 3 before, but now we will be doing enlargement. So, for enlargement, for enlargement, we need the scale factor. Is it enlarged by twice the size, or 3 times the size, or is it half the size? Okay, so we need the scale factor. But we also need what we call the center of enlargement, like in rotation. The center of rotation gave us the different location of the image. Okay, now in center of enlargement, it will also identify where the image is going to be placed. Now, in enlargement, we will be increasing or decreasing the size of the object, as I said, but the size of the angles remains the same. The size of the angle remains the same. Now, the image will not be congruent. They are not congruent. Why? Because in congruent, we said they are exactly the same, but now they are not. One is an enlargement of the other. So we say they are similar. And you will do more of this in year 11. If the center of enlargement is the origin, the 0, 0, okay, it is easy to find the new location of the item because you can simply multiply the coordinates by the scale vector, the coordinates of the vertices by the scale vector. Let's have a look at this one. Draw both axes from 0 to 9 and draw the shape ABCD having coordinates blah blah blah. Alright, so we have some space over here. Okay, plot axis, the x-axis and y-axis both from 0 up to 9. Okay. Starting from there. Zero, 1, 2, 3, 4, 6, 7, 8, 9. That is the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the y-axis. Now start plotting. 2, 1, 4, 1. 4, 2 and 3, 3. We have a 4-sided shape over here, okay? A quadrilateral, okay? And we should label that vertices A, B, C, D. So the first vertex, 2, 1 is A, B, C, D, okay? A is the first one, B, C, D, respectively, okay? Now, we need to draw the image of the shape after an enlargement of scale factor 2. So it's going to be twice as much. That is what scale factor 2 mean, all right? Twice as much. Center is 0, 0. Right? Now, I'm going to explain 2 ways on how you can do it. First thing I want you to realize is that if this shape has 2 squares in the bottom, how many squares will it have in the enlarged shape? Think about it. If it has 2, and it's going to be increased by scale factor of 2, so times 2, so that means the new enlarged shape is going to have 4 squares, 4 units in the bottom. The height of this part, BC, is going to be twice as much, so 2. Okay? The entire height of the shape is going to be twice as much, so 4 instead of 2. Now, I told you if the center of enlargement is 0, 0, I can simply multiply the coordinates by 2 to find the new vertices, the vertices of the image. So 2 is 4, 1 times 2 is 2, 4, 2. That's the first one. 4, 2. So our B is going to be over there. This one times 2 as well. We can only do this method, I repeat, because the center of enlargement is the origin. Okay? And I'm multiplying by 2 because the scale factor is 2. If it was 3, it means multiply by 3. So 4, 1 multiplied by 2, 8, 2. 4, 2 multiplied by 2, 8, 4. 3, 3 multiplied by 2, 6, 6. So 4, 2, 8, 2, 8, 4, and 6, 6. Use a pencil, okay? I'm going to use a pen just to show you the difference. And do confirm, is it twice as much the size? Yes, from 2 it's 4, from 1 unit it's twice, okay? So do check, okay? Now there is another method on how we can do this, and it is explained over here. Okay, so if the center of enlargement is the origin, it is easy because we just multiply the vertices and we find the new vertices. If it is not the origin, what do? We will have to measure the distance of each vertex from the center of enlargement and multiply it. So measure the distance of each vertex from the center of enlargement and multiply it by the given scale factor to find the position of the vertices of the image. So let me explain. This was the center of enlargement. To go to point A, we are moving 1, 2 to the right, and 1 up. 2 to the right, 1 up. Since we're going to multiply by 2, okay, instead of 2 to the right, we're going to move 4 to the right from the center of enlargement. 1, 2, 3, 4. And instead of 1 up, we're going to go 2 up. 4, 1, 2. There it is. Let's see, B. How far is B from the center of enlargement? 1, 2, 3, 4 to the right and 1 up. So now it's going to be twice as much. 1, 2, 3, 4, 5, 6, 7, 8 to the right and twice as much. Okay? How are we going to find point C? It's 4 to the right and 2 up, but we're going to multiply by 2, so it's 8 to the right, and instead of 2, 4 up. And we find the new location. D, it's 3 to the right, 3 upwards, so multiplied by 2, it's 6 to the right and 6 upwards. Okay, and that's correct. Another way of doing it. The distance from this to this, 2 to the right, 1 up. And repeat it again for 2 times, 1 and 2. Okay, to find B, 4 and 1. Again, 4 to the right and 1. We found it. To find C, 4 to the right, 2 upwards. Do it again because it's scale factor 2, so times 2, 4 to the right and 2 upwards. Okay, let's try it out in the next examples. You can try it out by yourself. So I need you to draw the shape with these vertices over here. Draw its enlargement by scale factor 2, so multiplied by 2, the shape is twice as large. The center of enlargement is not 0, 0, so you can't multiply the coordinates by 2, okay? The center of enlargement is 1, 4, so you will have to try out the method I was explaining before, okay? So start trying it out, and then we will check it out together. Let's try this out. Minus 3, 1, 3, 1, and 2, 3, and 0, 3. So we have a shape with 4 sides. And what is the name of this shape? Can you remember? It's got 2 sides that are parallel. Only opposite sides are parallel. That is called a trapezium. Okay? And the area of a trapezium is adding up the parallel sides, a plus b, times the perpendicular height on 2. Okay? You have to remember the previous topics. Okay? So, draw the enlargement by scale factor 2 from the point 1, 4. So, this is what we call the center of enlargement. So, what is the distance from this point to this point over here? It's 1 to the right, 1 down. And I'm going to repeat that because it is times 2. So, 1 right, 1 down, 1. And 1 right, 1 down, 2. That's it. So, that point will be over here. Now, this point, that is 1 left, 1 down. So I have the same thing, 1 left, 1 down, and again 1 left, 1 down. So I did that twice, and it is over here. Okay. So basically, I've already formed the top part of the shape. Now, this one. 1, 2 to the right, and 1, 2, 3 downwards. That's 1. Now repeat it again. 1, 2 to the right, 1, 2, 3 downwards. And it's going to be over here. This one. To go to this vertex, we need to move 1, 2, 3, 4 left, and 1, 2, 3 down. So 1, 2, 3, 4 left, and 1, 2, 3 down. And as you can see, this part was 1, 2, 3, 4, 5, 6 units. Okay, it had 6 squares. Now this part should contain 12. Let's check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. True. And join with the other points. Okay, you're going to have one shape in another shape. Don't get mixed up. And there is our new trapezium. Okay, that's one side. That's the other side. This is the bottom side, and this is the other side. Okay. If it was scale factor 3, then instead of 1 to the right, 1 down, we move 1 to the right, 1 down, again 1 to the right, 1 down, and again 1 to the right, 1 down for 3 times. Okay. To find this, for example, 2 to the right, 3 down, again 2 to the right, 3 down, again 2 to the right, 3 down. If it was scale factor 3. Okay. Now, what happens if the scale factor is a fraction? Okay, when the enlargement is by a fractional scale factor, in that way we are diminishing, we are decreasing the size of an object. Okay, if you have scale factor of half, what does that mean? A scale factor of half means half the size. Okay, so it will be half the size of the object, of the original shape. So start by drawing this one. Okay, and then I will explain how we're going to find the image. Minus 1, 1. Let me do the object in pen. 2, 1, and 1, 5. And that is A, B, C. So this is A, this is point B, this is vertex C, okay? So A, B, and C. Do label them, it's important. Okay, now I need to enlarge triangle ABC by scale factor of half. That is half the size times 1/2 or times 0.5. It's the same thing, okay? Times 1/2 or times 0.5. So this center of enlargement, and that's very important, is -1, -3. This is from where we're going to start counting. So to go up to A, you need 1, 2, 3, 4 squares up. But now we're going to do just half the amount. So we start from here again. Half the amount is 1, 2. Okay? And that is the new point. And the new point should be marked as A prime, we call it with the apostrophe, A prime. Okay? To go to B, it's 1, 2, 3 to the right and 1, 2, 3, 4 upwards. Now this is half the size. So half the size, start from here. Instead of 3 to the right, we're going to go 1.5. And instead of 4 upwards, we're going to go just 2 upwards. So it's going to be here between the 0 and the 1. And that is the B prime. Okay? Now from here up to C, we have 1, 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8 upwards. So 2 to the right, 8 upwards. We need half of that, so divide by 2 or times 1/2, okay? So divide by 2, we need just 1 to the right and 4 upwards. So from here, 1 to the right, 1, 2, 3, 4 upwards, and we will get C prime. Now you can join the vertices and we can confirm that the shape is correct. How? If the bottom of the triangle was 3 units, 3 squares, this one is half, well, 1.5. If it was 1, 2, 3, 4 squares high, now it should be 2. And yes, it is. Okay, so don't forget, you need the center of enlargement. You need to count the distance from the center of enlargement to the vertex of the object. Okay, and then multiply that distance by the scale factor. If it's 1/2, it's half the size. Divide by 2 or 0.5 times 0.5 or times 1/2. Okay, if it's scale factor 2, then multiply by 2. Scale factor 3, multiply by 3, etc. So after enlargement, the object and the image, are they exactly the same now? Are they exactly... Oops. Are they exactly the same? Are they exactly the same? No, they are not. They are similar, because it is a similar shape, but one is an enlargement of the other. So they are not congruent, but they are similar, as we said before. The angles of the image and the object, the angles when you have similar shapes, they are equal. They are the same. Okay? What can you say about the perimeter of the shapes under enlargement? I want you to think about this. Okay? Check each example we've done. Okay? Check the perimeter and see what is happening in terms of the perimeter. Think. You can measure using a ruler, or you can just count the squares. Think, what's happening with the perimeter? So, if we had the base twice, this was twice the size. If this was 1, this was twice the size. If this was just a diagonal, this was twice the size, 2 diagonals. Okay, so basically the perimeter is also being multiplied by 2. So what can you say about the perimeter? The perimeter is also enlarged or diminished by the scale factor. Okay, so if we multiply by 2, if the scale factor is 2, the perimeter is multiplied by 2. Okay, so that brings transformation to an end. Should you have any problems, do leave a comment or send me a message, okay, or email me, and I will explain further. Thanks for watching.